Swayam Prabha. Digital India. Educated India.
We reached some sort of halfway point. We considered the solar radiation processing and the optical efficiency for the flat plate collectors, and then we considered in detail the theory of flat plate collectors and various configurations, and then the principle of concentration, including that of a compound parabolic collector. Now, the next important thing should be not just the collector performance, but the system performance. As I was mentioning in the beginning of these lectures, that though collector is the heart of the system, but the overall performance will depend upon every component in the solar energy system. Like for example, what is the size of the solar tank for storage, and what is the efficiency of the heat exchangers, pipes, pumping, what is the bandwidth of the controls, etc., etc., etc. Before we embark on the system concept and the prediction, not just for a day or an hour, but for a long period of time like 1 year. 1 year is chosen because the meteorological cycle repeats itself in 1 year, and that will be an involved concept. So, we will have a little break here and go through some exercises, so that you will have a feel for numbers, and the choice of the problems and the locations mentioned or not mentioned is actually based upon to drive home a point. If the latitude changes, what changes? If the slope changes, what changes? If the season is different, what will be the differences, etc., etc., etc. So, this lecture shall be devoted to exercise 1. We shall try to solve as many numerical problems as possible in this 50-minute lecture, and then go on with the topics subsequently. So, this is exercise 1, and first I should acknowledge the source of Time Genie, which gave a compilation of latitudes and longitudes of important Indian locations. If you go through the web, I myself was surprised, you have an extensive list of latitudes and longitudes. Like for example, if you consider a state like Andhra Pradesh, starting with A, you have Anakapalli, Akkavaram, etc., etc., etc. So, I am giving these names because I belong to that state and I am more familiar, and you have hundreds under A, 100 under B, C, D, like that. So, but what I am showing here is only a partial list from the Time Genie. This is the Indian map, which shows the important locations, including Andaman, Nicobar Islands, and then you have got, I have put it in the form of a state and city, and state is in the italics, Andaman Islands, Andhra Pradesh, so on and so forth, latitude and longitude given in degrees and minutes. So, I might have made a little mistake here and there, that 9.9 degrees 09 minutes for Car Nicobar might have been treated as 9.09 degrees, right. Still it is a small error, does not matter, but nevertheless you should understand it is in degrees and minutes, and 60 minutes is 1 degree. So, you have got all the states in the alphabetical order. About 110 locations, longitude and latitude are given. You can go to the original web source and then have a larger number of locations, including this in a file, and in case there are any mistakes, you can correct, because it is a taken and then reformatted. In that process there might be few mistakes. So, the first question, the data etc., I shall in the next class will tell you where you can look for, and again they are available on the website. The first problem deals with, from the diameter and effective surface temperature of the sun, estimate the rate at which it emits energy and what fraction of this emitted energy is intercepted by the earth, and estimate the solar constant given the mean sun earth distance. This we have briefly discussed in the theory, but I shall go through the calculation procedure in detail. So, this is exercise number 1.1. T sun effective is 5762 Kelvin. Sun to earth distance is 1.495 times 10 to the power 11 meters. Though we have gone through all these things in the lectures, and probably these numbers also were given, but I felt a reiteration would be helpful for you to have an idea of the orders of magnitude involved. And diameter of the sun is 1.39 times 10 to the power 9 meters. So, energy emitted by the sun, E sun, will be sigma times area of the sun's surface area times T sun to the power 4, and you are assuming in this process epsilon sun equal to 1, and the Stefan Boltzmann constant sigma equal to 5.67 into 10 to the power minus 8 watts per meter square Kelvin to the power 4. You can check these numbers, but I believe my answers are correct, even if these numbers are a little wrong. I do not think they are wrong, but nevertheless give a pinch of salt. So, E sun is 5.67 times 10 to the power minus 8 into 22 by 7, that is pi, times 1.39 into 10 to the power 9 to square pi d squared into 5762 to the power 4, sigma area of the sun into T of the sun to the power 4, which shall be equal to 3.79 into 10 to the power 26 watts. So, this has got watts per meter square degree Kelvin to the power 4, degree Kelvin to the power 4 gets cancelled with this, meter square gets cancelled with this. So, I have got 3.79 multiplied by 10 to the power 26 watts. Fraction intercepted by the earth should be equal to pi d earth to the power 4 by 4 by 4 pi or sun earth square. Please note, pi d to the power 4 by 4 is nothing but the cross sectional area or the projected area of the earth, whereas of course, this is the spherical area of a sphere at or sun to earth radius. So, you have got 4 pi r squared instead of pi d to the power 4 as we have written in the case of the sun, because it is in terms of diameter. So, this should be equal to 1.27 into 10 to the power 7 square by 4. So, pi and pi get cancelled upon 4 times 1.495 10 to the power 11 whole squared. That should be equal to 4.51 times 10 to the power minus 10. So, it is a small fraction of the energy emitted by the sun that the earth captures. So, now if I want the solar constant GSC, which should be the solar radiation received by the surface normal to sun's rays at one sun to earth mean distance. So, the total amount of energy emitted is 3.79 times 10 to the power 26, which we have calculated, upon the corresponding area 4 pi 1.495 times 10 to the power 11 square, which comes to 1349 watts per meter square. If you recall, GSC is about 1353 to 1367, the estimates are changing, but we got a pretty close number, and this close number has something to do with the T sun. 5762 is assumed to be the sun's temperature, or you might call it a back calculation of the effective sun, because we are receiving a extraterrestrial radiation of about 1350 watts per meter square. Okay. So, we shall go to the next problem. These problems are picked up with a particular idea to drive home the point which we are trying to make through the lectures. The first one is nothing but a little bit of heat transfer, so that you know the radiation emitted by the sun through any spherical surface at a particular distance, the total amount remains the same, though the intensity changes. That is what we are trying to do, what we did, and what we receive on earth at a certain distance is inversely proportional to the square of the radius or the distance from the sun, and that is what we got. So, the second problem deals with calculate the angle of incidence of direct radiation at 11 o'clock solar time on January 20th at a latitude of 28 degrees north on surfaces with the following orientations. Throughout these exercises, we mean only the solar time, except when we state otherwise. So, the first one is a horizontal surface, then tilted to south at a slope of 35 degrees at a azimuthal angle of 25 degrees east of south, then vertical facing south and vertical facing west. So, these are the examples. So, theta at solar time 11 o'clock, that is right, which corresponds to omega equal to minus 15 degrees. Then you have got January 20th as the date given, and the latitude is 28 degrees, which is a high latitude within the Indian geography, and the declination will be 23.45 sine 360 times 284 plus n upon 365, and n will be 20 for January 20th, because n is the Julian day, counting one as January 1st, so on and so forth. Consequently, January 20th will have n is equal to 20. So, delta will be 23.45 sine 360 times 284 plus 20 upon 365. This is equal to minus 20.34 degrees, right. And if you calculate the sine of this number, will be 299.83. This will be 299.83. You can check up, and the answer turns out to be minus 20 degrees 20.34 degrees. So, you can intuitively it is correct, because it is January, n is equal to 20. It is a sort of winter, and declination should be negative, and I got the negative answer, this minus 20.34 degrees. You may recall our general equation of cos theta equal to A plus B cos omega plus C sin omega. I have deliberately chosen in the initial exercises, I am giving you again the equations in detail, so that you will recall, remember, whatever. And at a later date, I mean when we solve some of the problems, the details will be skipped, and I may just say that calculate the angle of incidence from the cos theta expression. But this is the way that we are expressing cos theta, which expanded. Once again, it is a reiteration, sin delta sin phi cos beta minus sin delta cos phi sin beta cos gamma plus cos delta cos phi cos beta cos omega plus cos delta sin phi sin beta cos gamma cos omega plus fifth term cos delta sin beta sin gamma sin omega. Now, you know of course, what are A, B and C. I am not going to spend a lot of time again writing what is A, what is B and what is C. So, we shall state this is the law, this is the equation which will take care of whether it is south facing, vertical or horizontal, or any gamma, beta, delta that you can give. Delta which we have already calculated as minus 20.34 for the January 20th. So, A horizontal surface, right. So, what we can have is beta is 0. This also becomes automatically independent of gamma. If you have a horizontal surface, the outer normal will be the zenith. The projection of that on a horizontal plane will be only a point. Consequently, it should not depend upon the azimuthal angle. There is no way to define the azimuthal angle, and very rightly the cosine theta expression reduces to be independent of the azimuthal angle when once you put beta equal to 0. So, you have got cos theta for a horizontal surface also equal to the zenith angle, so called cos theta z, which is cos phi cos delta cos omega plus sin phi sin delta. So, this should help you to sort of even remember these equations like I do, and you have I shall give little intermediate steps. So, cos 28 cos minus 20.34 cos minus 15 plus sin 28 times sin minus 20.34 is equal to 0.7948 minus 0.1628 equal to 0.6319. So, that your theta is equal to 50.8 degrees. So, you can check up whether this quantity is equal to this or not, and this is this or not. But the procedure is basically you calculate the cosine theta with the appropriate expression for cos theta from the general expression. In this case, beta is 0, and I have got a cos phi cos delta cos omega plus sin phi sin delta as the cosine angle of incidence for the horizontal surface, and theta equal to, of course, I can by notation say theta z also 50.8 degrees. Then B is your tilted to south at a slope of 35 degrees. So, gamma equal to 0, beta equal to 35 degrees. So, my cos theta will be cos phi minus beta cos delta cos omega plus sin phi minus beta sin delta, right. So, you can equal to cos, once again I am going in detail, in future we shall not so go so detailed. This is for you to be more and more familiar with the equations and be cautious whether it is plus, minus, etc. Also, I can finish my writing. So, cos phi minus beta cos delta cos omega plus sin phi minus beta sin delta will be cos latitude 28 degrees, slope 35 degrees times the declination minus 20.34 cosine of, and then the cos omega is minus 15 plus sin phi minus beta and then sin delta. So, this is equal to 0.8935 plus 0.041628. So, you check up these numbers because I have given only the two terms over here. this is equal to 0.935128. So, that cosine inverse theta will come to 20.75 degrees. Now, let us have a simple feel whether it is good enough estimate or not. So, it is south facing, okay, and the time is 11 o'clock, that is minus 15 degrees omega, and phi is 28 and beta is larger, beta is equal to 35. So, in winter in general, when the declination is negative, a higher beta is favorable. Higher beta favorable means theta will be lower, and which we have got a reasonably low theta 20.75 degrees, right. So, you have got gamma equal to 0, south facing ideal, and at the time 11 o'clock almost near the solar noon, and then we have chosen phi minus beta to be about minus 7 degrees, and that is a sort of a good orientation that one can have for your negative declination. And then C, we have a slope of 35 degrees, beta 35 degrees, but facing 25 degrees east of south. So, gamma will be equal to minus 25 degrees, right. So, that is what you have got, and now you have to wrestle through the full equation for cosine theta, which okay, for this example I will write incompletely. You can check up whether they are sine deltas or sine phi's and cos beta minus sine delta cos latitude phi sine beta, which is 35 times cos minus 25 gamma, and plus cos minus 20.34 cos phi cos beta and cos gamma, again plus cos minus 23.34 sine latitude sine slope cos gamma cos omega plus cos again delta sine of slope sine of azimuthal angle sine of omega. So, I shall not rewrite each term, but the final equal to 0.9597 and theta equal to 16.32. So, let us compare what we had earlier. This is 16.32. We earlier had for B theta is equal to 20.75. For C, theta is equal to 16.32. This is gamma equal to 0 and this is gamma equal to minus 25. Now, it is generally believed that a south facing surface is optimum for solar collectors. Now, I find that the angle of incidence when it is not due south, but somewhat towards east, seems to be better compared to gamma equal to 0, the south facing surface. Is it baffling? No, it is okay, because time is 11 o'clock. Minus 15 degrees is omega. So, you are towards east and you have oriented beta fairly well. Consequently, you have a better angle of incidence compared to even south facing surface, because the time is gamma is equal to 0. Okay? Omega is equal to minus 15 degrees. If you do the same calculation at omega is equal to 0, the south facing surface will have a better angle of incidence than the one with gamma equal to minus 25, right. Better angle means theta is lower. So, I can leave it check if theta equal to 0 is lower at theta omega is equal to 0. This is for gamma equal to 0. This is for gamma is equal to minus 25. So, if you have a east turn towards the east with a 25 degree angle and facing south with gamma equal to 0 degrees, you can check whether the angle of incidence for the south facing surface is lower or not at the noon time. Then we have D, that is a vertical facing south. Beta is 90 degrees, gamma is equal to 0, and I have written cos theta equal to, because gamma is equal to 0, I have a simpler expression, cos phi minus beta cos delta times cos omega plus sin phi minus beta times sin delta. That is all. So, you have got this equal to point 4251 plus 0.306. So, whatever is the number you can obtain here, this is 28 minus 90, that will be overall, this is no consequence, this is no consequence, because cos minus is cos plus also, and this is minus cos 9 theta is minus 3 cos minus theta. Consequently, this entire thing will be positive, and this is negative, along with this, it becomes overall positive, equal to 0.7313 leading to theta equal to 43 degrees. So, please remember, particularly in your exams, when the angle of incidence is asked, do not just stop at calculating cosine theta. You have to find out theta also. Now, we will go to E, that is vertical facing west, that is beta 90, gamma is plus 90. So, you have to involve the full equation, and to illustrate the point once again, I have written the full equation, which I shall also write the full equation in terms of cos theta equal to cos delta sin phi times cos whatever beta or gamma cos 90 degrees minus sin 34 cos 28 sin 90 cos 90. You check up with your original equation minus cos, probably this is plus, I think you can just check it up, cos minus 20.3 cos 28 cos 90 cos minus 15 plus cos minus 20.3 sin 28 sin 90 cos 90 cos minus 15. Oh, seems I have written 2 times, 1, 2, 3, 5. Okay, doesn't matter. You can just check up, doesn't matter. Cos minus 20.3 sin 90, again sin 90 times sin omega. So, in this is 0 because of cos 90, again 0 because of cos 90, this is also 0 because of cos 90, 1, 2, 3, and also is 0, and this is non-zero. So, you have ultimately minus 0.2427, that is only this particular, this is 1, this is 1, and sin minus 15, cos this is positive, so it becomes negative. Okay. So, theta turns out to be 104.04 degrees. What does this mean? It's more than 90, right? So, at 11 o'clock, it should not be surprising if your surface is oriented towards the west, it will not receive any sun's rays. So, theta will be more than 90 degrees. In this case, it turned out to be 104.04 degrees. It does not matter. The fact is, it is more than 90, and also physically you can realize that the surface oriented towards west shall not receive any radiation at a time before solar noon. So, we shall go to problem 1.3. The previous exercise is basically to tell you the difference between a horizontal surface tilted towards south and the effect of the time and whether it is off south facing like azimuthal angle being west or whatever, right. So, naturally you can relate that the angle of incidence should be most favorable at around solar noon if it is towards south, and not so favorable, I mean larger, if it is off south, depending upon the time. If it is towards east, 11 o'clock will be better, and if it is towards west, maybe 2 o'clock, 2 p.m. may be better, right. So, this should not come as a surprise, but nevertheless, this is an exercise to learn the orders of magnitude as well as what one can expect qualitatively from a south facing surface, horizontal surface tilted at a particular angle more than the latitude or less than the latitude, which will come a little later. So, this 1.3 deals with the calculate the angle of incidence of direct radiation at 11 solar time on June 20th at a latitude of 35 degrees north on surfaces with the following orientation. So, we just have two things which I wanted to demonstrate for some purpose. Vertical south, same thing vertical and north. So, and latitude is 35 degrees. So, phi is 35 degrees n, which means we in the northern hemisphere. Time is 11 o'clock, which implies omega is minus 15 degrees, and the day is June 20th. Consequently, n will be 31 for January, 28 for February, 31 for March, 30 for April, 31 for May plus 20, which shall be 171. So, that my declination delta is given by 23.45 sin 360, 284 plus 171 upon 365. Okay. So, this turns out to be 23.45 sin 44867 equals to, it's a large number, you can calculate it, 23.45 into 0.999 equal to 23.4 degrees. I am happy because we know in June the maximum declination will be around June 23rd, which is equal to 23.45 degrees, and around June 20th with all this calculation including sine of 448.767, I got the answer 23.4 degrees. So, it should be okay. Now, A, beta 90 degrees, gamma 0. So, cos theta will be cos phi minus beta, cos delta, cos omega plus sin phi minus beta sin delta. Okay. So, which is equal to 0.999 4756 minus 0.325, which is equal to 0.1504, from which we can calculate theta 81.34 degrees. So, you will realize the latitude is reasonably high, 35 degrees. It is June, so the sun will be pretty much high up, and almost the solar noon, because it is 11 o'clock. So, you have a pretty high angle of incidence, some sort of unfavorable angle of incidence, right, 81.34, where the maximum possible is only 90. B, vertical facing north. So, beta is equal to 90 degrees, gamma is equal to 180 degrees, right. Cos theta is sin 23.4, sin 35, cos 90 minus sin 23.4. You can check up with your full equation whether I am writing phi beta deltas correctly or not, because at times I might have got the correct answer, because whether I write cos 90 because beta is 90, or sin some zeros because something else is 0, I may get away with that equation, but nevertheless you please check up. Cos 90 cos omega plus cos delta sin phi sin 90 cos gamma cos omega plus cos delta sin 90 sin gamma sin minus 15, which is omega. So, that overall turns out to be minus 0.1833. So, theta which essentially means if you have got a vertical surface facing north at 11 o'clock, obviously it will not receive any sunshine, which is indicated by theta being more than 90. So, let us go to the next example, that is 1.4. Yes. So, determine the sunset hour angle and day length for Srinagar and for Port Blair for the following dates: December 23, March 22nd and June 23rd. This problem has been chosen among the data that we have got. Srinagar has reasonably, if not the highest high latitude within India, and Port Blair, if not the lowest, but the low latitude, and December, March and June, they represent the maximum negative and maximum positive declinations, along with March being a 0 declination. So, it should be able to make us understand the variation in the day length and or the sunset hour angle depending upon the latitude and the season. So, sunset hour angle is nothing but cosine inverse minus tan phi tan delta. And for December, do not worry about 21st or 23rd or 22nd. Okay. So, I will take it as delta minus 23.4 degrees, and March 22 to 0 degrees. So, if you want, you can say approximately, and June 23rd okay. The issue is it is 0 here, these are 23.4, 23.4 maximum negative and positive values. Or you can calculate, if you want to be fussy, 23.45 sine 360, 284 plus 2, or rather sorry, n upon 365. Okay. And as we have taken the data from Time Genie, and you can see in the first few pages of the exercises chapter, this chapter, and Srinagar has a latitude of 34.05 degrees. Sorry, this should be, I think, minutes, though it does not make much difference. Port Blair, you can check up whether it is 34 degrees or 05 minutes or 34.05 degrees. There will be a slight difference, do not worry about it. I might have calculated as the calculator did. So, both are north latitudes. So, we will first consider Srinagar, December 23. So, omega s will be cosine inverse minus 0.6757, that is cos phi, times minus 0.4327 cos delta, cos inverse of tan phi tan delta. Tan delta is negative, so delta is negative, tan delta is negative, and this minus is in the formula, and this is tan phi. So, this is equal to cos inverse 0.2923, which is 73 degrees. This is omega s, n s, the number of sunshine hours will be twice 73 by 15, which will be 9.73 hours. So, as far as this lecture is concerned, we shall stop over here, but the important point is Srinagar, December, winter at a reasonably high latitude, you have got the number of sunshine hours 9.73. This is a 0.73 because I calculated, and I know for sure it is not 73 minutes, but 0.73 hours, which will be 0.73 into 60 minutes. It is considerably lower than 12 hours, which normally we think daytime is 12 hours and night is 12 hours. But if you go to a high latitude and winter, you have considerably less number of sunshine hours. Okay? We shall continue with these problems and discussion in the next class, which will give us some more feel for the numbers and how the climate and the latitudes, or rather climate in the sense season, time of the year, and the latitudes with the orientation will relate themselves. Thank you.